Hello students, welcome to another lecture on logic design. In this video we will talk about how to convert a decimal number into binary. There are two methods to convert a decimal number to binary: sum of weights and double dabble. In this video I will explain the sum of weights method. This method is normally used for small numbers. Also, you need to remember the powers of 2. For your reference, I have on this slide the positive powers of 2 listed in table 1 and the negative powers of 2 listed in table 2. To better understand this method, let us take an example. Convert 163.875 to the base 10 to an equivalent binary number. Notice that this example has an integer part and a fractional part. Let us take the integer part, that is 163. We have to find the largest number which is a power of 2 but does not exceed 163. Let us refer to the table of positive powers of 2. We find that 2 raised to 7, that is 128, is a number which is a power of 2 and does not exceed 163. So we record it. Next, we find the difference between 163 and 128. We are left with 35. We do the same process again. We find a number which is a power of 2 but does not exceed 35. We find that 2 raised to 5 is 32, a number which is a power of 2 and does not exceed 35. So we record it. We find the difference 35 minus 32 and now we are left with 3. Doing the same process again, we find a number which is a power of 2 but does not exceed 3. 2 raised to 1 is 2, a number which is a power of 2 and does not exceed 3. So we record it and find the difference 3 minus 2 equals to 1. We do the same process again and find a number which is a power of 2 but does not exceed 1. So you see 2 raised to 0 is 1, which is a number which is a power of 2 and does not exceed 1. So we record it. Now we find the difference 1 minus 1, which is equal to 0. Since the difference is 0, we stop. Make a note of the powers of 2 that were recorded. 2 raised to 7, 2 raised to 5, 2 raised to 1 and 2 raised to 0. In the same example, let us now take a look at the fractional part, that is 0.875. For this, we will refer to the negative powers of 2 which are listed in the table. We have to find the largest fraction which is a power of 2 but does not exceed 0.875. We find that 2 raised to minus 1 is equal to 0.5 is the largest fraction which is a power of 2 but does not exceed 0.875. So we record it. Find the difference between 0.875 and 0.5. We are left with 0.375. We do the same process again. We find a number which is a power of 2 but does not exceed 0.375. 2 raised to minus 2 is 0.25, a number which is a power of 2 and does not exceed 0.375. So we record it. We find the difference between 0.375 and 0.25, which is equal to 0.125. Doing the same procedure again, we find a number which is a power of 2 but does not exceed 0.125. From the table, we see that 2 raised to minus 3 is equal to 0.125, a number which is a power of 2 and does not exceed 0.125. So we record it. Find the difference between 0.125 and 0.125, which will result in 0. Since the difference is 0, we stop. The powers of 2 that are recorded here are 2 raised to minus 1, 2 raised to minus 2 and 2 raised to minus 3. To conclude, we have recorded the integer part and the fractional part. The powers of 2 which make up the integer part are as follows: 2 raised to 7, 2 raised to 5, 2 raised to 1 and 2 raised to 0. The powers of 2 that were recorded for the fractional part are 2 raised to minus 1, 2 raised to minus 2 and 2 raised to minus 3. To complete the binary number, we add 1 for the power of 2 that is present. We add 0 for the power of 2 that is absent. Therefore, the integer part of the binary number becomes 1 for 2 raised to 7. Since 2 raised to 6 is not present, we make it a 0. 2 raised to 5 is present, so we make it a 1. 2 raised to 4, 2 raised to 3 and 2 raised to 2 are not present, so we put zeros. 2 raised to 1 is present, so we put a 1. And 2 raised to 0 is present, so we put a 1. Similarly, the fractional part of the binary number becomes 1, 1, 1. Since 2 raised to minus 1 is present, 2 raised to minus 2 is present and 2 raised to minus 3 is present. Thus, the complete binary number becomes the following. That's all for now. We will continue with the binary number system conversions in the next video. Try your hand at decimal to binary conversion with the following numbers. Connect to the classroom for further videos and learning material.